In this video, we are going to review subtracting numbers by using the additive inverse. Before we get to the rules of subtraction, we're actually going to look at a couple different scenarios and explore a couple different techniques for subtracting integers. So let's start by looking at how we can add 5 plus negative 3 and also how we can subtract 5 minus 3 using algebra tiles. If I want to model 5 plus negative 3 using algebra tiles, I'm going to have 5 positive tiles and 3 negative tiles. Now if I match up positive and negative tiles, I create a zero pair. In this case, I get 3 zero pairs. And with these zero pairs, I can remove them to find my total sum. So 5 plus negative 3 is positive 2. Now let's look at the same situation but using 5 minus 3. If I want to model this situation using algebra tiles, I'm going to start out with 5 positive tiles. I want to take 3 of those tiles away to represent the subtraction. So 5 minus 3 is also equal to 2 positive tiles. So if we notice that these two problems gave us the same value, we've kind of discovered what adding the opposite and subtraction really are related. Subtracting a number is the same as adding the opposite of the number. So we can use the rules of addition to actually solve subtraction problems. So one technique to solve problems is using by algebra tiles. Let's look at a technique using a number line. If I want to model 6 minus 4 on the number line, the first thing I will do is change it to adding the opposite. So 6 plus negative 4 can be modeled on the number line by starting at 0 and going right 6 spaces. And then if I want to add negative 4, I'm going to start at 6 and add negative 4 by going left 4 spaces from 6. That leaves me now pointing to positive 2, so 6 plus negative 4 is positive 2. Let's see what happens when we now try to subtract negative 6 minus 4. So for negative 6 minus 4, again, I will start by rewriting that as adding the opposite. So I'm going to rewrite that as negative 6 plus negative 4. So to model this problem using the number line, I'm going to go left 6 spaces to represent the negative 6, and then adding negative 4 is going to add another 4 units to the left. So now my arrow is pointing at negative 10, so negative 6 plus negative 4 is equal to negative 10. Let's see what happens when we do 6 minus negative 4. Again, I'm going to start the problem by changing it to addition, so I'm going to get 6 plus positive 4. Modeling that on the number line, I'm going to go 6 units to the right to model the first 6. And then if I want to add positive 4, I'm going to go another 4 units to the right from 6. And notice I'm now pointing at 10 on my number line. So 6 plus positive 4 is 10. Let's look at one last example to see really what's going on here. 12 minus 15, I'll rewrite as 12 plus negative 15. To model this on the number line, I'm going to start by going 12 units to the right from 0. And now when I want to add on negative 15, I have to go 15 units to the left from 12. I actually go past 0 and end up pointing to negative 3. So 12 plus negative 15 is negative 3. Now this technique is great when our numbers are small, but there has to be some better ways to work these problems out. So let's think about what's going on, and let's try to solve a few problems without using a number line. So we already know that subtraction is really adding the opposite of a number. So we can change all of these to addition and then follow the rules for adding integers. So when we want to subtract integers, what we're really going to do is rewrite the expression by adding the opposite and then follow the rules for adding integers. Quick little summary, if the two signs are the same, we'll add the two numbers and give our answer the sign of the numbers. If the signs are different, we ignore the signs, find the difference, or subtract the two numbers, and then we give the answer the sign of the number with a larger absolute value. So I've picked a few problems just to practice using this new technique for subtracting integers. So let's look at a few examples of this. For negative 55 minus 3, I started by rewriting it as negative 55 plus negative 3, adding the opposite. Since the signs were the same, I really want to add the two numbers together. And since both were negative, when I add them, I'm going to get negative 58. For the next example, 12 minus 36, I'll start by rewriting that as adding the opposite. So that'll be 12 plus negative 36. Since the signs are different now, I want to subtract the two numbers and then keep the sign of the number with the larger absolute value. So 36 minus 12 is 24, and since 36 has the larger absolute value and it was a negative number, my answer is actually going to be negative 24. For 20 minus negative 14, now again I'll change that to adding the opposite, so I'll rewrite that as 20 plus positive 14. Since the two signs are the same, I'll add my two numbers and keep the same sign. So 20 plus positive 14 is going to be 34, and since they were both positive numbers, my answer will stay positive 34. Now that we've looked at these problems with just using two numbers, let's see what happens when we throw more numbers into the mix. So for 35 minus 15 minus negative 6, what I will do when my problems get a little bit more complex is break them up into pieces. I'll start, however, by writing the entire thing as adding the opposite. So 35 plus negative 15 plus positive 6. Then as I break it up into pieces, I'm going to focus in on just the first two terms to get the problem started. So I'm going to look at just 35 and negative 15 to begin the problem. Off to the side, if I look at this, the signs were different. So that means I want to subtract the two numbers and keep the sign of the number with the larger absolute value. So 35 minus 15 is 20, and 35 has the larger absolute value, and it was positive. So this is going to stay a positive 20. So what I'm going to do is replace those two numbers in my problem now with just positive 20. I'll bring down the rest of the problem so that I can finish solving it. So I'm going to bring down the remaining plus positive 6, and now I'm going to finish up. These two numbers have the same sign, so we'll add them and keep the positive sign. So 20 plus 6 is 26, and it is going to stay positive 26. So as you work these problems out, you really want to just be looking for adding the opposite of the numbers first, and then follow the rules for adding your integers. It's just a quick summary. If the signs are the same, you would add the two numbers and give your answer the sign of the numbers. And if the signs were different, you would ignore the signs, subtract or find the difference of the two numbers, and then give your answer the sign of the number with the larger absolute value. Now that we've done 3 different techniques for subtracting, I think you're ready to try a few on your own. Go ahead and pause the video to practice these 5 problems. You can use the number line, algebra tiles, or our adding the opposite technique and follow the rules for adding integers to solve these problems. When you're ready, resume the video and you can check your solutions. Here are the answers to the 5 practice problems. Notice that I did all of these by adding the opposite and then following my rules for addition. If you need to review any of the problems, feel free to review the video again and re-practice the problems again.